Okay, so this next one, we have, all I did here was I changed it from the square root to the 1/2. And so, to find the derivative, we're going to use the chain rule again. And so, the first thing is this guy being raised to the 1/2. So, you bring it down. 1/2, and then you leave the inside alone. Everything inside is going to be left alone. So cosine of e to the x plus 1 over x minus 1 to the minus 1/2. Okay, and then we get the derivative of the inside. So the derivative of cosine of this stuff is, so that's going to be a negative sine of the inside, leaving it alone, times, now we move in one level in, so times the derivative of the inside. Well, the derivative of the exponential is just itself, times the derivative of its inside, which is this quotient, which means that we're now going to have to multiply by and use the quotient rule here. So remember, the quotient rule, the denominator is always squared, and you always just get the derivative of the first, which is 1, times the second, x minus 1, minus the first times the derivative of the second. And that's it. We're done. Okay, so in this problem, our outside function is this guy that's being raised to the 1/2. And so the derivative is equal to, you'll bring the 1/2 down, and then you leave the inside alone. So I'm going to leave it as arcsine of 4x minus 3 over x squared plus 7. All to the negative 1/2, because you subtract 1. Okay, and then times the derivative of the inside. Okay, so the derivative of the inside is, remember, the derivative of arcsine, well, that's 1 over the square root of 1 minus x squared, but this time we don't have x squared, we have 4x minus 3 over x squared plus 7. And this guy is going to be squared. So because I don't have just an x here, I have to use the chain rule, which means I have to plug in whatever it is that's the argument of arcsine. So instead of x squared here, I would have 4x minus 3 over x squared plus 7 squared. Okay, but then I have to multiply by the derivative of the inside of arcsine, which is this quotient. So that means that over here I'm going to use the chain rule. And so on the denominator I'm going to have x squared plus 7 squared. And then on the numerator Now I'm just going to use my normal chain rule. So I get the derivative of the first, which is 4, times the second, which is x squared plus 7, minus the first, leaving it alone, times the derivative of the second, which is 2x. And now that I've gone the furthest in I can go, then I'm done.